In this video, we are going to look at some exam-style questions that require the use of operations with polynomials. Well, let's get started with the first question. Consider the equation x squared plus 8x minus 20 equals x plus c in brackets times x plus d in brackets. So we have a quadratic polynomial on the left-hand side and the product of two factors on the right-hand side, and we have to determine the values of c and d, which are non-zero real numbers. So let's start by expanding the brackets using the distributive law. Before we do that, we have to start, because this is an equation, we have to write everything from left to right. So I've written the terms on the left-hand side, and now we start multiplying the brackets using the distributive law. X times x equals x squared plus x times d, which I'm going to write it as dx because we usually write the variable at the end. It doesn't matter in a product whether you have d times x or x times d. Then we have plus cx plus cd. The same thing here, we could write cd or dc, but we usually write the letters in alphabetical order. The next step is collecting like terms. You can notice that on the right-hand side of the equation, we have these two like terms. How are we going to collect them? Well, we are going to take x common factor. So if we take x common factor on the right-hand side, we end up with x squared plus d plus c in brackets x plus cd. The next step now is, because we have equality, we know that two polynomials are equal if corresponding coefficients are equal. What do I mean by corresponding coefficients? That means that the coefficients of x squared are equal, the coefficients of x are equal, and the constant terms are equal. So let's see what happens. The coefficient of x squared on the left-hand side is 1, and the coefficient of x squared on the right-hand side is 1. So they are equal. Now we have to look at the coefficients of x. On the left-hand side, the coefficient of x is 8. On the right-hand side, the coefficient of x is d plus c. Because the polynomials are equal, we can write this equality. 8 equals d plus c, and we are going to denote this with equation 1. Now we are going to look at the constant terms. The constant term on the left-hand side is negative 20. The constant term on the right-hand side is cd, so we can write another equation. Negative 20 equals cd. I want you to notice that I took the negative here of the constant term because the negative is part of the term. I have to take it here. Now what we have is, this is equation 2. So we have a system of simultaneous equations in c and d. From the first equation, I'm going to write d in terms of c. So d equals 8. If we take c to the other side, it becomes take away c. With this one, we substitute it into equation 2. So let's see what happens. Now we have negative 20 equals c bracket. So instead of d, I'm going to have 8 minus x. So notice that instead of d, I put 8 minus c. Now let's solve this equation. If we expand the brackets on the right-hand side, we are going to end up with negative 20 equals 8c take away c squared. Now this one is another quadratic equation, so I'm going to write it. I'm going to move all the terms to the left-hand side. So we end up with c squared minus 8c take 20 equals 0. At this point, we have to solve this quadratic equation in C. So if we look at negative 20, we have, let's find two numbers that multiply to give us negative 20. So that would be 2 and negative 10. 2 times negative 10 is negative 20. 2 take 10 equals negative 8. So here are the solutions. So you have C, take away 10, C plus 2. If we use the Null Vector Law, I'm going to have C minus 10 equals 0, or C plus 2 equals 0. So I'm going to have C equals 10, or C equals negative 2. All we have to do now is substitute these values back into this equation here to determine the values of D. So let's see. D equals eight, take away C. So let's take the first value. 10 equals negative 2, or D equals 8, take away negative 2, and we end up with 8 plus 2, which is equal to 10. So C equals 10 and D equals negative 2, because negative 2 is the value of D when C equals 10, or C equals negative 2, like here, and D equals 10. So either of the two combinations are correct, and that makes sense because this becomes x plus 10 times x minus 2, or we can have it the other way around, x minus 10, x minus 2, sorry, x plus 10. Either way is correct. The next equation I'm going to look at, the next question I'm going to look at is just a little bit different. So what we have to use here, you can see that the first, we have a polynomial and there is an unknown here, and this unknown is a. So we have to determine the value of a such that p of 2 equals 1. What does that mean? Well, this means that if I substitute x equals 2 into this polynomial, the value of p equals 1, and let's see what that does. So p of 2 equals 2 times 2 to the power of 4, take away 8 over 3 times 2 to the power of 3 plus a half. My advice to you here is just take your time, because it's better to spend a little bit of time rather than rushing here, because there are so many numbers and operations, so you have to be very careful about this. Now we know that p of 2 equals 1, so we can replace this with 1 equals, now 2 times 2 to the power of 4, that gives us 2 to the power of 5, and that's 32. Take away 2 to the power of 3 is 8, so 8 times 8 is 64, divided by 3, plus 2 times 3 is 4, 4 divided by 2. Actually, what I'm going to do here, because I like to cancel down, so let's cancel down these two with the power. It's a lot easier to try to cancel down wherever you can, because you make the numbers smaller. So you end up with 2 here, take 2a, take away 5. I just want to stop here just for a second, because I have noticed that many of my students do have problems when they have to multiply a fraction, like this one here, by a number. 2 to the power of 3, so I'm going to write it as 8. Now, when you multiply a fraction by a whole number, that means that you actually multiply two fractions. You can put 8 over 1 because 8 divided by 1 is 8, so the 1 doesn't change the value of the function of the fraction. So when we multiply fractions, we multiply the tops together, so 8 times 8, which is 64, and we multiply the bottoms together, so that gives us 3 times 1, which is 3. So this is why I ended up with 64 over 3. So be very careful when you work with fractions. Know your fractions. I know many students have struggled with that. Anyway, so what I'm going to do now, I'm going to simplify what I can. I'm going to keep the 1 here. 32 plus 2. I'm going to try to make this easier. 32 plus 2 is 34. Take away 5. We end up with 29. Take away 64 over 3 minus 2a. Now, we have fractions here, and you are required to know to use fractions, operations with fractions. So let's see what we are going to do here. In order to subtract these two, I'm going to multiply this number by 3 over 3. I do that because I want the same denominator for these two fractions. So I'm going to have 29 times 3, which is, I'm going to write the 1 first. 29 times 3, which is 87. Take away 64, divided by 3 minus 2a. Let's see what this becomes. We have 1 equals 87 minus 64, that leaves us with 23 over 3 minus 2a. What I'm going to do now, I'm going to move this term from the right-hand side of the equation to the left-hand side of the equation. What I tend to do, to move the term that has a negative in front of it, because if you move the negative, that's going to become a positive on the other side. So it's a lot easier to work with positive values. And now we are going to move the 1 to the other side of the equation. So we have 2a equals 23 over 3 minus 1. Well, we are going to do exactly the same thing here because we have to subtract 1. So we multiply it by 3 over 3. And we are going to end up with 2a equals 23 minus 3, which is 20 over 3. To determine the value of a, we have to divide this fraction by 2. Now, I'm going to stop here, and I'm going to do this separately because, again, many students struggle with this. So I have to divide both sides of the equation by 2. So if I divide both sides of the equation by 2, this 2 is going to cancel this one, so I'm going to end up with a on that side. But on this side, I have 20 over 3 divided by 2. Well, just remember, when you talk about fractions and you have division, what happens? Recall that this symbol changes into times, This 2 is actually 2 over 1, so what do we do with it? We flip it over, so it becomes 1 over 2. So basically, this is going to cancel the 20, and we end up with 10 over 3. So the value of a, such that the polynomial given, when x equals 2 equals 1, then a equals 10 over 3. Now we have the value of a. What we are asked to do is evaluate p of negative 1. So what we have to do, we have to substitute negative 1 for x. So we have 2 times negative 1 to the power of 4, take away 8 over 3 times negative 1 to the power of 3, plus a half times negative 1 squared. I want you to notice that the negative 1 has to be in brackets because both the number and the sign are to that power. The number itself is negative 1. Now we have take away a, but now we know that a is 10 over 3 times negative 1, take 5. Now, negative 1 to the power of 4 is actually 1, so we end up with 2 here. Negative 1 to the power of 3 is negatives, and with this negative makes positive, 8 over 3. I want you to notice how I always work out the sign first, because if I work out the sign, I take that one out of the way, and then all I have to worry about is just the number. Negative 1 squared is 1, so I end up with plus a half. Negative and negative makes positive, so it's plus 10 over 3, take 5. So let's do some calculations here. 2 take negative 5, I'm going to continue it here. 2 take 5 is going to be negative 3. 8 plus 10, just notice that these two fractions, 8 over 3 and 10 over 3, can be added up straight away. So 8 plus 10 is 18, divided by 3, that gives us 6, plus a half. So basically we have 3 plus a half, which is actually 3.5. So p of negative 1 equals 3.5. Another thing that I want you to notice is that I write the answers always at the end. So I have the answer fully written here at the end of the question, and I have the answer fully written here at the end of this question. For part C of this question, we have to determine an expression for p of 2n. So this time we have to substitute a term that consists of a number and a letter. So let's see how we go with this one. P of 2n equals 2 times 2n to the power of 4 minus 8 over 3 times 2n to the power of 3. And again, I put this in brackets because both 2 and n are to the power. Plus a half 2n to the power of 2. Take away 10 over 3 times 2n minus 5. So let's simplify this. We have 2 to the power of 4, which is 16 times 3 is 32. And we have n to the power of 4. Take away 2 to the power of 3, which is 8. 8 times 8 is 64 over 3 n to the power of 3. And again, notice how I work out the sign first, and then the number, and then the pronumeral. So I have 2 to the power of 2, which is 4, divided by 2, that gives us 2n squared. Take away, 10 times 2 is 20 over 3n minus 5. Again, when I multiply here, I multiply 10 over 3 times 2 over 1. So 2 times 10 is 20, and 3 times 1 is 3. And basically, this is the answer to this question. And again, I'm making sure that I write this nicely at the end. The last step has to show the answer. All right, and the last question I have here is, we have two polynomials. Now, these two polynomials are of degree 3, so they are cubic polynomials, and there are two unknowns, p and q, and we have to determine these values knowing that the two polynomials are equal. So, let's get started again. We look at the coefficients of x cubed, 7 and 7, they are fine, so we don't have to worry about those ones. Now, the coefficient of x squared in polynomial A is negative, so again, remember to take the negative with you as well. So negative bracket 2p minus 15. So let's write this here, what we know. So we know that a of x equals b of x, which means corresponding coefficients, coefficients of corresponding terms are equal. So negative 2p minus 15 equals p. The coefficient of x squared here is just p. And now we continue with the coefficients of x. Now the coefficient of x in A of x is 21, and the coefficient of x in B of x is negative 3q. So let's write another equation. (21) equals negative 3q. Again, I need the negative as well. So what we have here, we have a system of two simultaneous equations that actually we can solve them separately, because this one is an equation in P and this one is an equation in Q. So actually our life is a lot easier here. Let's expand the brackets on the left hand side here. Negative 2p plus 15 equals p. And again, I'm going to stop just a little bit here to make you aware of the fact that just remember, when you multiply by a negative, this negative in front of the bracket, it's actually, just think of it as a negative 1. So you have negative 1 times 2p equals negative 2p, and then you have negative 1, because what we do here, we use the distributive law again. So we have negative 1 times negative 15, and for this reason we have plus here. So just remember that. Unfortunately, again, many students forget that. So I'm going to move this term to the other side. And remember, I said I like to move the negative terms so they become positive. It just makes life easier. So what's left on the left hand side? 15 equals p plus 2p. So we end up with 15 equals 3p. At this point, what we have to do, we have to divide both sides of the equation by 3. So if we divide by 3, that cancels that. So we end up with p equals 5. And I'm going to make sure that I let everybody know that this is the answer. From the second equation, what we do, we solve it. It's just a linear equation. So from here, if we divide both sides of the equation by -3, we end up with 21 divided by -3 equals q, or q equals, a positive and a negative makes negative. 21 divided by 3 equals 7. Again, notice how I work out the sign first. It's so much easier if you work out the sign, then you don't have to worry about it. So -7. So the values of p, the value of p is 5 and the value of q is -7.